Imagine a traveler coming from another star system, silently crossing our solar system, only to be struck head-on by the fury of the sun. That's exactly what happened with 3I Atlas, only the third interstellar object ever discovered. The odds of a solar ejection hitting it were less than 1 in 1,000. Yet, against all probabilities, the impossible unfolded before our very eyes. And what we discovered from this impact may change the way we understand the cosmos. Imagine a wanderer from the depths of interstellar space, cutting across our solar system on an unlikely trajectory. This traveler is 3I Atlas, an object carrying with it the secrets of another sun, another place. Now, add to this one of the most powerful forces of our star, a coronal mass ejection, CME. When these two worlds collided, an event so rare was born that it left science breathless. We're not talking about a simple cosmic encounter. We are witnessing something that happens once in many generations. The sun, at the peak of its activity, hurled a colossal cloud of plasma and energetic particles into space. And by sheer coincidence, or fate, that plasma crossed directly into the path of 3I Atlas. The improbable became reality before our eyes. Astronomers call this a statistical anomaly, but for us, the curious, it's almost like watching the universe challenge its own rules. The impact not only altered the appearance of the interstellar comet, but also opened an unprecedented scientific window. It was as if the cosmos had handed us an unexpected gift. Before we even understand the impact, it's important to remember that this traveler already carried with it the weight of rarity. It's not every day that something from another star system enters our cosmic backyard, but to be struck so precisely by a solar eruption places 3I Atlas on a pedestal of singularity. And here arises the first big question. Was this collision merely a coincidence, or is there a deeper pattern we have yet to see? The answer may lie in the details of the comet's journey and in the reactions revealed by the impact. Get ready, because this is not just another astronomical report. This is the story of one of the most improbable encounters ever recorded. A story that reminds us the universe is still full of surprises. What happened to 3I Atlas in the hours after the impact is the kind of thing that would belong to science fiction, if it weren't real. Telescopes around the world turned their eyes toward it, capturing every detail. But perhaps the most fascinating question isn't just the impact itself. It's the thought of how probable it was for this to happen exactly at a time when humanity has the technology to watch it in real time. A cosmic stroke of luck, perhaps. This is the kind of event that redefines how we look at the night sky. Suddenly, the invisible becomes a spectacle, and the improbable invites us to question statistics. The improbable, after all, does happen. And so, we begin with the first layer of this story, to meet up close the protagonist of this encounter. Who, after all, is the mysterious 3I Atlas? The interstellar visitor. 3I Atlas is only the third interstellar object ever confirmed. Before it, we had the eccentric Oumuamua in 2017 and comet Borisov in 2019. These objects were not born here. They are travelers from other star systems, ejected from their stellar homes and launched into deep space until crossing paths with our solar system. The name 3I means exactly that, third interstellar. The acronym ATLAS comes from the telescope that detected it, a Hawaiian system designed to track asteroids and comets. Its discovery was already historic in itself. After all, each interstellar visitor carries a time capsule from another corner of the galaxy. What makes this comet even more special is its trajectory. Unlike the comets we know, which usually come from the Oort cloud or the Kuiper belt, 3I Atlas follows a retrograde orbit, that is, in the opposite direction of the planets and most bodies of the solar system. That alone makes it a true outsider. On top of that, its speed is staggering. It cuts through space at more than 60 kilometers per second. For comparison, Earth orbits the Sun at 30 kilometers. That means 3I Atlas is moving twice as fast as our own planet. This speed is the unmistakable signature of its interstellar origin. Each observation of this object offers clues about how other star systems form and evolve. The composition of 3I Atlas may be very different from comets that were born around our sun. And it was precisely this difference that made it the perfect protagonist for such an explosive encounter with solar energy. When scientists studied its structure, they noticed it was releasing large amounts of carbon dioxide, far more than water, something unusual for local comets. This seemingly small detail may be the key to understanding the spectacle that followed the CME impact. 3I Atlas is not just a chunk of ice and dust wandering through space. It is a messenger from another sun, carrying chemical secrets unknown to us. That explains why its reaction to the solar shock was so intense. And this singularity makes it a rare star on the cosmic stage. If it was already unique just for existing, being struck by a CME elevated it into a phenomenon that astronomers could only dream of witnessing. Thus, this interstellar visitor stopped being just a strange comet and became a true cosmic laboratory. But how exactly did this impact unfold? That's what we'll explore in the next chapter. The impossible speed 3I Atlas travels through space at more than 60 kilometers per second, which is the equivalent of covering the distance between New York and Los Angeles in under a minute. This insane speed is not just a technical detail, it is the clear signature that we are dealing with an interstellar body. No local comet moves this fast. For astronomers, this means it is not bound to the sun. Unlike comets in our solar system, which orbit in predictable cycles, 3I Atlas is only passing through. It entered our cosmic backyard, and soon enough, will continue its journey into intergalactic emptiness, never to return. Its retrograde orbit adds even more difficulty. While planets and most comets follow the same direction around the sun, 3I Atlas moves the other way, like a car speeding the wrong way down a highway. That makes any encounter with another object, or with a solar ejection, almost impossible. And yet, that's exactly what happened. A coronal mass ejection, hurled from the sun at millions of kilometers per hour, managed to intercept this moving target. Statistically, it was such an improbable event that many scientists compared it to hitting a bullet in midair with another bullet fired in the opposite direction. This speed also has another fascinating implication. Every collision with solar particles is amplified. Instead of a gentle interaction, the shock becomes even more energetic. It's as if space itself had decided to turn this visitor into a stage for extreme experiments. Speed, therefore, is not just a number. It is the key that made the impact so impressive. Without it, the event might have gone unnoticed. With it, the universe presented us with a luminous and scientific spectacle unlike anything before. This accelerated motion also challenges astronomers. Any observation attempt has to be timed down to the second. A small delay could mean missing the phenomenon entirely. It is a race against time to record every detail before the interstellar traveler disappears. Despite the difficulty, this urgency also heightens the excitement. Every image, every data point collected becomes a rare treasure. After all, once 3I Atlas is gone, there will be no second chance. Speed is both a challenge and a gift. Thus, 3I Atlas is not just fast, it is a reminder of how relentless the universe can be in its cosmic dance. A body racing against time, leaving behind a brief yet unforgettable trail in our astronomical history. And it was precisely this speed that transformed the CME impact into a true spectacle. But to understand how everything aligned, we must look at the other protagonist of this story, the sun, at one of its stormiest moments. The sun at peak activity. The sun goes through cycles of about 11 years, alternating between calm phases and periods of intense activity. Currently, we are living at the height of solar cycle 25, a time when sunspots, eruptions, and coronal mass ejections become much more frequent. It's as if our star were boiling over. During these phases, CMEs, giant clouds of plasma and magnetic fields, are launched into space at astonishing speeds. Each one can carry billions of tons of particles, capable of sweeping across the solar system and interacting with planets, comets, and even Earth itself. Normally, these solar storms are monitored because they can disrupt our technology, satellites, communications, power grids. But this time, the target was far more improbable. The sun's energy ended up intersecting with the path of an interstellar visitor. This coincidence makes the event even more fascinating. It wasn't just the force of nature on display, it was the meeting of two extremes, a raging sun and a comet from another corner of the galaxy. The collision was both inevitable and almost impossible at the same time. The exact moment of impact was tracked with great anticipation. Models predicted that the CME had only a few hours in which it could cross paths with 3I Atlas. It was like waiting for two giant ocean waves to collide in mid-sea. And the telescopes confirmed it. The impact happened. This interaction didn't just distort the comet's tail, it also revealed secrets about its composition. As the solar wind slammed into material released by 3I Atlas, gases and dust lit up in new ways, creating both a visual and scientific spectacle. Astronomers were amazed. This wasn't just another solar eruption, it was a rare chance to observe how an object from another star system responds to the power of our sun. In other words, the sun had turned 3I Atlas into a natural laboratory. This kind of opportunity is unique. Even if the sun throws off thousands of CMEs over the centuries, the chance of one hitting an interstellar object in transit is nearly zero. The fact that it happened at the peak of solar cycle 25 only highlights how extraordinary this coincidence was. Moreover, this event reminds us of something important. The sun, though it sustains life on Earth, is also a chaotic force. Its unpredictable behavior can both challenge us and surprise us with rare scientific opportunities. And so, in this atmosphere of maximum energy, 3I Atlas was struck. Now that we know the two protagonists, the interstellar traveler and the furious sun, it's time to understand what the impact itself truly meant. The improbable target picture. The scene. Billions of tons of plasma hurled from the sun in every direction, traveling through space at speeds of up to 2 million kilometers/h. Now think about the immensity of the solar system and the tiny size of an interstellar comet racing across the void. The chances of one of those solar waves hitting such a moving target? Less than 1 in 1,000. Astronomers compare this probability to shooting an arrow at a grain of sand flying at full speed through the desert. It sounds exaggerated, but it's a fair analogy. Space is vast, the targets are minuscule, and such encounters are incredibly rare. And yet, it happened. The CME and 3I Atlas crossed paths with almost choreographed precision. This type of coincidence is so uncommon that it was immediately classified as a high-level statistical anomaly, the sort of thing that might take centuries to repeat. That improbability is what makes the event so fascinating. It wasn't just a physical collision, but a collision of statistics. One of those moments when the randomness of the universe creates a spectacle that feels scripted by a cosmic storyteller. What makes it even more intriguing is that this happened during a time when other equally rare events were unfolding. 2 novas bright enough to be seen with the naked eye, and 2 strong earthquakes in Venezuela. Scientists called it the 72-hour stack, one of the most extraordinary clusters of rare events ever recorded. For scientists, this doesn't necessarily mean there's a direct connection between them, but the timing makes the event feel even more mysterious. After all, how often does nature deliver such an improbable sequence of phenomena? This sense of improbability explains why the impact of 3I Atlas was celebrated so widely in the scientific community. It not only provided unprecedented data, but also served as a powerful reminder that the unexpected can happen at any moment. And this improbable nature is not just a statistical curiosity, it's also the key to understanding how science advances, by seizing every rare opportunity the cosmos gives us. The universe may be random, but every anomaly holds valuable information. The impact of 3I Atlas, then, was a blend of luck and science. Luck, because we witnessed something so unlikely, and science, because we were able to observe, measure, and learn from it. And it was precisely in this improbable encounter that we began to uncover more about the interstellar visitor. But how exactly did the impact itself unfold? That's what we'll see now. The moment of impact. On September 25, 2025, solar models indicated that a coronal mass ejection was about to sweep across the inner solar system. Scientists knew there was a slim chance it might hit 3I Atlas. And then, as predicted, the collision happened. A historic moment for astronomy. When the plasma cloud reached the interstellar comet, the impact was immediate and visible. The tail of 3I Atlas distorted, stretched, and glowed in unusual ways. Telescopes around the world captured the transformation in real time. It was like watching a light show in space. But the spectacle wasn't just visual. The solar wind interacted with the gases and dust of the comet, revealing details of its composition. Astronomers observed intense releases of carbon dioxide and even color shifts, something extremely rare in such observations. They described this as a natural experiment that could never be recreated in a laboratory. The universe itself had offered a unique opportunity to see how an interstellar traveler reacts to the raw power of our sun. The event was followed by some of the most advanced instruments on Earth and in space, including the James Webb Space Telescope, ground-based observatories, and even amateur astronomers. The global cooperation turned this into one of the most documented impacts of the decade. The images showed not only the reshaping of the comet's tail, but also fluctuations in its brightness. It was as if 3I Atlas had been shaken by the shock, sending out visible signals to all who were watching. For scientists, every second of this event was precious. The data gathered may help decipher not just the composition of the comet, but also how solar plasma interacts with material from beyond our solar system. The moment also revealed a striking contrast. On one side, the sun's uncontrollable fury. On the other, the fragility of a frozen body drifting silently through space. Their collision was a reminder of how the colossal and the fragile meet in the cosmos. This was not just an impact. It was a spectacle, a collision that entered history as one of the rarest and most studied encounters between two cosmic worlds. A true gift to science and to human curiosity. And in this context, we can now explore the three great curiosities that make this event even more fascinating. The first of them, the statistical impossibility that defies all calculations. The impossible statistics. The first curiosity about the impact of 3I Atlas is precisely how statistically impossible it seemed. In raw numbers, the probability of a coronal mass ejection directly hitting an interstellar object is estimated at less than 0.1%. This means that even if we waited thousands of years, we might never witness something like this again. This calculation takes into account the immensity of space and the rarity of visitors like 3I Atlas. We're not talking about a local comet, orbiting the sun in predictable cycles. We're talking about a body from another star system, passing through our cosmic backyard only once in all of human history. It's like throwing millions of dice in the air and expecting all of them to land showing the same number. Scientists call this a statistical outlier, something so improbable it seems to defy the very logic of randomness. Yet, as we've seen, the improbable does happen. This improbability didn't go unnoticed. Many researchers pointed out that the impact occurred during the same period when other extremely rare events were unfolding. 2 novas visible to the naked eye and 2 magnitude 6 earthquakes in Venezuela. This was the so-called 72-hour stack, which has already become a kind of jargon in scientific circles. And that overlap is what gives this curiosity even more weight. Each event, by itself, would already be rare. But all of them compressed into such a short window creates the feeling that the universe was playing with the statistics. There's no evidence of a direct connection, but the coincidence is hard to ignore. For the public, these probabilities may sound abstract. But think of it this way. If we usually see maybe 1 naked eye nova per year, and here we had 2 in less than 3 days, the unusualness becomes clear. Add to that the impact on an interstellar visitor, and the math starts to feel impossible. This first curiosity shows us that even in a universe ruled by physical laws, randomness can still generate incredible spectacles. The improbable is not the impossible, and sometimes we are lucky enough to witness it. Astronomers stress that such events don't just change our statistics. They remind us of the need to always keep watching the skies because we never know when the next impossible might unfold. That's the beauty of science. To record, study, and learn from what once seemed far too improbable to exist. 3I Atlas was the perfect stage for that reminder. And here comes the second curiosity. Beyond defying the odds, the impact transformed the comet into something even more valuable for science, a true natural laboratory. A natural laboratory. When the coronal mass ejection struck 3I Atlas, it did more than distort its tail. It turned the interstellar visitor into a unique scientific experiment, something impossible to replicate in Earth-bound laboratories. For the first time, we had the chance to observe how an object from another star system responds to the power of our sun. The impact allowed scientists to study plasma interactions under conditions never seen before. The solar wind, loaded with energetic particles, swept through the comet's coma, revealing which gases were released, how they behaved, and even how their colors shifted. It was a hands-on astrophysics lesson on a cosmic scale. What made it even more fascinating is that 3I Atlas carried with it a chemistry different from what we're used to. While most comets in our solar system release water as they near the sun, Atlas turned out to be dominated by carbon dioxide. This detail completely changed the way it reacted to the solar strike. The event also provided a rare chance to directly compare the effects of space weather on local versus interstellar bodies. Such comparisons may help answer long-standing questions about how different planetary systems form comets with such varied properties. For solar physicists, the impact worked like a natural plasma experiment. It allowed them to measure in real time how a CME interacts with ice, dust, and gases from another system. That expanded our knowledge not only of the comet, but also of the sun itself. This kind of data is priceless. For decades, astronomers have studied CMEs hitting solar system comets, but never before had they witnessed this type of interaction with an interstellar object. 3I Atlas was the missing piece of that cosmic puzzle, and like any good laboratory, it also brought surprises. The comet's response to the CME was far more intense than expected, suggesting that its internal structure may be weaker or more volatile than that of local comets. That, in turn, raises new questions about its origins. Beyond the scientific impact, the event also captured the public's imagination. The idea of an alien visitor being struck by the sun in our cosmic backyard is the kind of story that blends science with poetry. This second curiosity reminds us that sometimes the universe creates its own experiments and lets us watch. Our role is simply to be prepared to capture every detail, and it was precisely in this natural laboratory that the third curiosity emerged. The comet's change in color, a dazzling transformation that made 3I Atlas even more mysterious. The green window. Just days before the impact, something unexpected was already catching astronomers' attention. 3I Atlas seemed to be changing color. Its reddish hue was giving way to a bright green glow, visible even to amateur telescopes. This transformation intensified even more after the solar ejection. The explanation for this lies in the comet's chemistry. Substances like cyanide and carbon dioxide, when excited by solar radiation, emit a green light. The CME impact increased the release of these gases, creating a rare and astonishing spectacle. This phenomenon isn't common among solar system comets, which tend to show whitish or bluish tails due to water vapor and carbon monoxide. But 3I Atlas, being interstellar, revealed a different chemistry, almost alien by our standards. Watching a comet light up green in space is like seeing a lantern turned on in the cosmic void. The change was not only aesthetic, but also scientific. It revealed an intense and unusual chemical activity. The solar impact didn't just distort the comet's tail, it amplified this coloration, making it even more striking. It was as if 3I Atlas had been placed under a cosmic spotlight, showcasing its uniqueness to the maximum. This visual transformation captivated not only scientists, but also amateur skywatchers. Reports came from all over the world describing the excitement of witnessing the vibrant green glow against the dark sky. For astronomy, these color shifts are invaluable. They work as chemical signatures, helping scientists identify what compounds make up the comet and in what proportions. Each hue tells a cosmic story. In this case, the green revealed the presence of rare, unstable compounds, possibly formed in stellar environments very different from our own. 3I Atlas carried with it the memory of a distant sun, recorded in its volatile chemistry. Thus, this third curiosity is more than just a visual detail. It's a reminder that the universe speaks to us in colors, and each color carries a hidden history. 3I Atlas revealed its true shade at the very moment it was most impacted. And color wasn't the only clue. The comet's overall composition also revealed unexpected secrets, setting it apart radically from everything we've ever seen in our solar system. The mysterious composition. When scientists studied 3I Atlas with telescopes such as the James Webb Space Telescope, they found something astonishing. Its activity was not driven mainly by water, like the comets we know, but by carbon dioxide, CO2. This ratio immediately stood out. Normally, CO2 shows up in small amounts in solar system comets, but in the case of Atlas, it dominated, about 8 times more CO2 than H2O. This is a clear indicator that it formed in an environment radically different from ours. This suggests that 3I Atlas may carry ices and chemical compounds that have been preserved since the birth of another star system. In other words, it is a time capsule from another world, offering clues about the diversity of cosmic chemistry. When the Sun released its CME, this unusual composition became crucial to the spectacle. The CO2 released into space interacted with the solar plasma in unexpected ways, intensifying the comet's visual transformation. This also helps explain why the comet reacted so strongly to the impact. Carbon dioxide is more volatile than water, meaning it is released more easily when heated or disturbed, causing bursts of light, gas, and dust far more dramatic than we normally see. For science, this raises new questions. Do different star systems produce comets with radically different compositions? Is 3I Atlas a rare exception or a common sample of what lies beyond our neighborhood? Every spectrum collected during the impact is a treasure trove of information. It allows astronomers to compare alien comets with local ones, searching for patterns or fundamental differences. This mysterious composition reinforces the idea that the universe is far more diverse than we imagine. What we see in our solar system might just be a small slice of the chemical possibilities spread across the galaxy. Thus, 3I Atlas is not merely a comet passing through. It is a messenger from beyond, reminding us that the cosmos holds a variety of worlds and materials well beyond our everyday experience. And it is precisely this chemical singularity that makes every observation of 3I Atlas so valuable. But it wasn't observed alone. An army of telescopes around the world and in space tracked every detail of this cosmic encounter. The eyes of the telescopes. When news broke that a coronal mass ejection might collide with 3I Atlas, a true scientific mobilization began. Telescopes around the world and satellites in space were redirected to follow every detail. It was a race against time to capture each moment of the cosmic spectacle. The spotlight was on the James Webb Space Telescope, JWST, which, with its infrared sensitivity, was able to detect the release of gases and dust in unprecedented detail. Its images showed not only the deformation of the comet's tail, but also its unique chemical composition. Ground-based observatories also played a vital role. From Chile to South Africa, telescopes recorded variations in brightness and rapid color changes in 3I Atlas. These observations were shared in real time, creating a global web of data. Even amateur astronomers joined in. Using modest equipment but good positioning, they managed to capture the comet's green glow, contributing valuable information to the scientific community. NASA, ESA, and other space agencies coordinated large observation campaigns, combining data from different instruments. This collaboration highlighted the importance of collective science in the face of unique events. The records weren't limited to visible light. X-ray and ultraviolet detectors picked up energetic signatures of the impact, revealing processes invisible to the naked eye. It was like watching the same phenomenon in multiple dimensions of light. Each telescope provided a piece of the puzzle. Together, they offered a detailed, multi-layered picture of the encounter between the interstellar comet and the fury of the sun. Never before had such an event been documented with so many resources at once. This massive data collection turned the impact into one of the most studied astronomical events of the decade. Hundreds of papers and reports began to emerge almost immediately, fueled by thousands of observations. Global participation also gave the public a rare sense of connection, the feeling of following science unfold in real time. News and images spread within minutes, bringing space closer to daily life. And thanks to this sharp collective eye, we were able not only to witness what happened, but also to understand what this impact truly means for science. The scientific meaning. The impact of 3I Atlas by a CME goes far beyond astronomical curiosity. It represents a unique opportunity to expand our understanding of how different cosmic materials react to solar energy. This encounter allowed scientists to observe plasma interactions under conditions never before seen. It was as though the universe itself had provided us with a natural laboratory, where the Sun and the interstellar comet performed an experiment beyond human reach. From a scientific perspective, the event offers clues about the origins of 3I Atlas. Its CO2-rich composition suggests it may have formed in a region much colder than our solar system, preserving volatile ices uncommon in our neighborhood. Studying how the CME affected its tail and color also helps scientists predict how interstellar comets might behave in other systems. This broadens our view of the diversity of planetary environments across the galaxy. Another crucial point is that the impact served as a test for our solar models. Observing how plasma interacted with the comet validated simulations and improved predictions of how solar storms might affect not only comets, but even Earth. For astrobiology, the event has exciting implications. If complex molecules can survive CME impacts on interstellar comets, this strengthens the hypothesis that life's building blocks could travel between stars, a concept known as panspermia. The scientific meaning, therefore, lies not only in the event itself, but in the doors it opens for future research. Every data point collected now will fuel decades of studies. This was the first time we observed something like this, but it may not be the last. Knowing it's possible to track such events prepares science for new cosmic encounters in the future. In the end, the impact of 3I Atlas wasn't just an astronomical curiosity. It became a key to understanding the relationship between the Sun and interstellar visitors, revealing how our star interacts with material from other worlds. And to grasp how unique this truly was, we must place it in a larger context. The improbable sequence of phenomena scientists have already nicknamed the 72-hour stack. Connections with other events. The impact on 3I Atlas did not happen in isolation. It was part of a period that has already gone down in the history of astronomy and geophysics, the so-called 72-hour stack. Between September 23 and 25, 2025, the universe seemed to concentrate a sequence of improbable phenomena into a very short window of time. Within that period, 2 novas exploded with such power that they became visible to the naked eye. To give perspective, on average, we might observe just 1 naked-eye nova per year, and sometimes none at all. This time, 2 appeared in less than 2 days. Meanwhile, on Earth, Venezuela was shaken by 2 magnitude 6 earthquakes within less than 6 hours, an extremely unusual occurrence for the region. To top it off, a strong aftershock was recorded soon afterward. And crowning this sequence of events, the CME struck 3I Atlas, creating an interstellar spectacle documented in real time. 4 rare events, all compressed into just 3 days. For statisticians, this is an example of a Poisson cluster, when unlikely events align purely by chance. For the public, it felt almost like a cosmic message, as if the universe had decided to throw out the book of probabilities. Even without causal connection between them, the temporal closeness made scientists reflect on how rare it was to witness so many high-energy phenomena in such a short time. Each event by itself would already be historic. Together, they formed a record that is nearly impossible to ignore. This overlap also helped popularize the expression 72-hour stack. Today, it's already circulating in academic circles as shorthand for weeks when nature decides to deliver the extraordinary. For astronomers, this convergence was a unique chance to test observation protocols and rapid response systems. In just a few days, telescopes, observatories, and scientists had to mobilize quickly to record every detail. The stack of events reinforced the importance of continuously monitoring both space and Earth. After all, we never know when the improbable will repeat, and we can only understand its value if we are ready to capture it. And with that sense of expectation, the question arises, what comes next for 3I Atlas in the months ahead? What comes next? After the CME impact, the journey of 3I Atlas through the solar system is far from over. Its trajectory includes close passes that promise to bring new opportunities for study, and perhaps more surprises. The first major milestone will be October 3, 2025, when the comet will pass just 0.19 astronomical units from Mars. This flyby will allow orbiting probes like TGO and MAVEN to attempt unprecedented measurements of its composition. Next comes October 29th, when 3I Atlas will reach its perihelion, the closest point to the Sun during this passage, about 1.36 astronomical units away. This will be a critical moment, when its activity is expected to peak. If the release of gases and dust increases as predicted, the comet may become visible to skilled astronomers even during dawn or dusk, though with extreme caution when observing near the Sun. Later, on December 19th, 3I Atlas will make its closest approach to Earth, at about 1.8 astronomical units. Though this poses no danger, it will be the best chance for amateur telescopes to observe it. These dates are already generating great anticipation in the astronomical community. Citizen science networks and independent observers are preparing to capture images, measure brightness, and record possible changes in its tail. Each of these stages is a fresh chance to study an interstellar visitor under conditions we've never encountered before. The CME impact was only the first chapter of a story that is still unfolding. Whether through space probes, giant telescopes, or even binoculars, 3I Atlas will continue to be tracked intensely. After all, it will never return. This is a once-in-a-lifetime opportunity. The ongoing monitoring could reveal further color changes, brightness variations, or even possible fragmentations caused by the Sun's heat. Every detail will be documented with maximum care. And so, 3I Atlas continues its journey, reminding us that astronomy is, above all, the art of watching the unexpected. But before it leaves us, we must reflect on what this event truly means on a larger scale. The impact of a coronal mass ejection with 3I Atlas was not just a rare event. It was a powerful reminder that the universe still holds secrets we cannot even imagine. In a cosmos so vast, witnessing such a statistically improbable coincidence is like finding a needle in an ocean of stars. This encounter showed us that even amid apparent chaos, nature creates spectacles that defy our understanding. The improbable became real before our eyes, reminding us that randomness can also be beautiful. Atlas, with its exotic composition and unique trajectory, was already special on its own. But after being struck by the Sun, it became a natural laboratory, a stage for cosmic experiments no scientist could have dreamed of creating. Every color shift, every change in its tail, and every data point collected is part of a larger puzzle. Together, they reveal not only the secrets of this interstellar visitor, but also clues about distant star systems. The coincidence with other rare events, like novas and earthquakes, only reinforced the sense that we lived through an extraordinary moment. A stack of improbabilities that will be remembered as both a statistical and scientific milestone. But perhaps the greatest lesson lies in perspective. By watching the improbable unfold, we are reminded that the universe does not follow our expectations. It writes its own narrative, full of surprises, and invites us to be attentive spectators. This event also highlighted the value of collaboration. From giant telescopes to amateur binoculars, every eye contributed to forming a more complete picture. Science is, after all, a collective endeavor. As 3I Atlas continues its journey into the unknown, we are left with the memory of its brief visit, a reminder that every moment of observation might be our only chance to witness something unrepeatable. In the end, the story of 3I Atlas is the story of human curiosity, to look up, to seek explanations, and to marvel at what once seemed impossible. It is confirmation that even in an infinite universe, there are moments that connect us deeply to the mystery of existence. And so we close not just a scientific account, but also an invitation. Keep looking up, because the next impossible could happen at any moment, and you might be the first to witness it.